Hello guys, today we are going to talk about integrations, and in today's video we are going to talk about technique of integrations. Okay, so hold on. Okay, so today we are going to talk about the first technique of integration. Technique of integrations. There are a lot of technique of integrations in Kao 2, but today we are going to talk about integration by part. Okay, so I'm sorry, yeah, not integration. Okay, so firstly, we need to know the formula. The formula of integration by part, and it's quite easy to define. We can say it's u dv. The integral of u dv is equal to uv minus integral v du. Okay, so this will be the formula for integration by part. And first of all, we need to know how can we use integration by part in different problems. Okay, so in high school, we learn about how to integrate normally or integrate by separations. So let's say we know how to integrate of x to the fourth. This is simple, right? You add the power to the 5 and you divide by the power, the n plus 1, okay, and you plus c. This is what we taught in high school. However, sometimes the problem of integration can be complicated. So for example, we have a problem like the integral of x e to the x dx. So in this case, we can't just add the power by 1 and divide by the power plus 1, because we have an x here and we have an exponential here. We have two different expressions of x. One is algebraic, one is exponentials. So how do we do this type of problem? So when you see two different type of like algebraic and exponential or natural log or whatever trigonometrics, we can apply integration by part. So remember the formula. We have u, so yeah, I would say the formula is uv minus integral v du. This is the formula in order to find using integration by part. However, what is u, what is v, and what is du in this case? So you have to choose either one be u and either one be dv. So we will form a table like this: u dv. Okay, I will not. Okay, so this is how I approach u, and I form a du and v prime and v. So we have 4 equal sign. Okay, so we have to choose u, and we will differentiate the u, we will get du, and we have to choose v prime, and we can integrate the v prime to get v. So how do we choose u and v prime? In this case, I would recommend you a strategies or a tips. We always choose u by the following patterns: LATE, late. So what does it mean? It means logarithm, algebra, trigonometry, and exponentials. So we always choose u for logarithm if there is a logarithm there. If there's no, we choose the algebraic, which is x squared, like a polynomial functions. If there's no polynomial, then we choose trigonometry as a u, and so on. Okay, so we will always choose u for logarithms. And in this case, if you notice, we have algebra, which is a, we have exponential, which is e. So it's obvious we choose u as x. Okay, based on this pattern or tips, so we choose u equal to x. And what if you differentiate du? You could get dx, right? This is simple. Simple math, simple differentiation. And when you choose u, you know that the another one will be v prime, just will be e power of x. And when you integrate e power of x. Okay, remember to put the x here, yeah, because dv we must equal to e power of x dx. So when you integrate v prime, basically you integrate e power of x dx, you'll get back the same, right? E power of x. And you don't have to plus c here because this is just a working show of working, like how do you put into this formula, okay? After that, you can just use the formula. You got you have v, you have v and du. So you can just put uv equals x times e to the power x, x times e to the power x. The integral will be, okay, so I will recommend you to write like this, okay? Integral x e to the x dx equal uv. uv is x times e to the x minus integral v is e to the x, du is dx. And you found out that we have an integral here again. So we just, however, this integral is much simplified or simple compared to the first one. So we can just evaluate, we can just solve it directly. Integral of e power x will just be e to the power of x. So you will get minus e to the power x. And now you have to write a plus c because it's the final answer. And the integral of x e to the x dx will eventually equal to this answers, okay? Okay, so this is how you solve integration by part. You like how you solve an integral using integration by part, okay? So let's give an example, okay? We can start with an example. Okay, so another example will be integral of ln x dx. So in this case, is we can't just integrate directly, right? We can't integrate ln x. We can integrate 1 over x. 1 over x dx is equal to ln x plus c. But not in log. But we can't integrate ln x. So we have to think of one way. We have to think of strategy or technique to integrate these functions. So we know that we might be able to use integration by part. So let's try. We have u and we have du. I will write like this. Okay. So u. In this case, we have a tips, right? U late logarithm. So it's obvious. Ln x is a logarithm. So we can just choose u as ln x. Okay, due to the tips here, late ln x. So du, what will be du? It's just differentiate of ln x. We can differentiate, but we can't integrate ln x. Okay, so this. How about v prime? Do you see anything you can choose as v prime? No, right? It's just ln x. It's just a logarithm. However, in this case, you know that here is a 1. It's a 1 multiplied by a ln x. 1 multiplied by anything is equal to it will be the same as long as it's 1 times ln x. So in this case, we can choose 1 as the v prime because you have nothing to choose left, right? You have nothing. So we can choose 1 dx. Okay, then we integrate this. Integrate of 1 is what? It's just x. Okay, and we just apply the formula. Ln x in the integral of ln x dx is equal to uv is ln x times x minus integral of v, which is x du, 1 over x dx. So what x and x cancel, it will become 1 dx. And we just compute this integral. This is a very simple integral, okay? So we can get x ln x minus x plus c, and this is your final solutions, okay? So this is your final solution for integral of ln x. And now we prove a integral for ln x is equal to x ln x minus x plus c. And as you see, when you learn about integration by part, you can solve a lot of problems with 2 different type of functions like algebraic, exponentials, trigonometry, or logarithm. Even inverse trig, you can use integration by part. Okay, so yep, this is the introduction of integration by part, and we will move on to more complicated example in the next video, and we will do some new topics of integration techniques. Okay, thanks for watching. Hi guys, I'm Jefferson Bentley, and thank you for your time and watching my videos. Subscribe and like and share. Peace.